So good morning, ladies and gentlemen, distinguished dignitaries and excellencies, colleagues and my dear friends. We welcome you once again to the International Energy Agency's annual 11th edition of the annual Global Conference on Energy Efficiency. This is another very high-level panel on AI for efficiency, and I am Reena Suri, Executive Director of India's Smart Grid Forum, a forum which has been working since 2011, supporting the government and various utilities on their transformation journey, making the grid smarter. And it is my pleasure to be here once again with this, and being part of this very important conversation. And an honor to moderate, this important discussion today, and to be joined by such high-level accomplished and diverse panel of leaders who have joined us today from bringing perspectives from government, industry, technology, and regulations. So please allow me to introduce and welcome on stage our distinguished panelists for this session. I would request you to please join me welcoming with a huge round of applause to His Excellency Dorin Jungato, Minister of Energy, Government of the Republic of Moldova. Very warm welcome, Mr. Minister. He's an energy expert with more than 16 years of international experience, and he has led and delivered major energy projects across Europe and the Middle East, and also leading the country's efforts on energy security, market reform, and clean energy transition. Most welcome, and you can take any seat, as you like. Next, we have Her Excellency, Ms. Asako Anohino, Deputy Commissioner for International Affairs, Agency for Natural Resources and Energy, and Ministry of Economy, Trade, Industry from Japan. And she is bringing deep expertise on energy policy, international cooperation, and efficiency strategy. Very warm welcome, Ms. Asako. And next we have Ms. Rachel Fleischer. She is the Group Director, Regulation and Economics, Octopus Energy. A very warm welcome, Ms. Rachel. And she is bringing extensive experience in utility, regulation, market design, and consumer-centric energy transition. Please join me in welcoming our next panelist, Mr. Julien Guénette, Executive Vice President, Alfa Laval, and is bringing decades of leadership in industrial energy efficiency, process optimization, and sustainable industrial systems. And last not the least, we have Ms. Mary Spray-Regan, Global Head of Regulatory Affairs and Market Development, Oracle Energy and Water, and working extensively at the forefront of digital transformation, utility, modernization, and AI-enabled energy transition. Welcome, Mary. And thank you all for joining us here today. So with the perfect mix of, the leaders we've been able to rope in today for this very important session, this panel brings an extensive expertise together, exactly the kind of perspective we need for today, because AI is no longer, just a technology conversation, but it is the beginning of central to the future of energy efficiency. And across the world, we have seen that we are already seeing AI shaping, how the energy systems are operating, and how we are generating, distributing, and consuming, and optimizing the electricity in our respective countries. And from predictive maintenance in industrial systems to load forecasting, and also in the power networks, and to optimizing the building's energy load, integrating renewables that are coming in. So AI is enabling the complete, helping us with the shift towards more intelligent, faster, and more precise decision making. And coming with some perspective from India, where I'm coming from, this is a transition which is unfolding at a very, very large scale. So we operate one of the world's largest networks, and it's one of the most complex electricity network systems that our operators are dealing with. And we are serving over 300 million consumers, and through various initiatives of Government of India, we've been able to bring a lot of digitalization in our power systems, and also with 250 million smart meters that are being rolled out under the Government of India scheme. The broader digital power sector reforms, and the Government of India's active building towards the digital foundation is already being laid with all these kind of transformations. So it's worth noting that India has been actively shaping the global conversation of artificial intelligence, and the Government of India recently hosted in this year, February, the very first Global Artificial Intelligence Summit in India, which was attended by thousands from around the world. So that shows that we are really seriously looking at transforming and bringing smartness into, and the digitalization into our grids, and using this technology, to make our systems better. And India Smart Grid Forum, we are working very closely with the governments, regulators, and utilities to translate this vision into practice. And we have recently launched an artificial intelligence handbook, which covers 174 case studies from around the world and India, covering generation, transmission, and distribution altogether. I'm very happy to share that more than 30 are coming from India itself. The AI is already at the forefront of transformation, and India is looking at that. And alongside, we are also supporting the utilities in pilot deployments. We have with so much now data coming in from smart metering program, and utilities. We still were thinking till yesterday how to deal with so much of data. But thankfully, we have many AI platforms which are helping us analyze the data and make use of it to better forecast, better manage, and going to the granularity of what appliance, how much the usage from each one. So that's the kind of support we can get with the data, and AI playing a key role in bringing the analytics for the system operators. And at the same time, India's industrial efficiency programs, such as Perform, Achieve, and Trade scheme, they have already demonstrated how the policy and it can drive large-scale efficiency improvements. And also AI, now gives us a powerful opportunity to further deepen and accelerate all the gains that we are looking for. So, but still, we are, there is a critical challenge, and with the advantage that it's bringing. We are also seeing the AI is emerging as one of the most powerful tools, but also, and of course, supporting the efficiency for the sector. But it is also contributing to rising electricity demand through expanding data centers and growing computational intensity. So the question before us today is not simply how to deploy AI, but how we deploy it responsibly and with inclusively and also efficiently. And to begin, I would like to invite each of our panelists to share their opening perspective, and let us let us start with one question for all the panelists. And let me start by inviting His Excellency Dorin Ungato, Minister of Moldova. So I will begin with you, and would have one question for all of you from your national and the organizational perspective. Where are you currently seeing the greatest opportunity that AI is bringing, and to improve on the efficiency, energy efficiency front. And I understand that you are leading already in the middle of profound energy transition and also integrating the European energy markets while building the digital foundations needed for the future. So what's your perspective, from Moldova's side? Where is the greatest opportunity you see, Mr. Minister?
Thank you very much for the question. When we speak about artificial intelligence in the energy sector, mostly we speak about technologies. But before AI could deliver any value, countries must build the digital platform, the digital ecosystem, the digital background on which the AI will operate. And in my view, the government should not see, I would say, the digital infrastructure, the skills required to develop it, the regulations and the investments necessary for it as competing. They are all part of the same endeavor, and they are all necessary. However, in order to develop all this, the initial point is data. It's how we accumulate, how we store, how we process, how interoperable is the data necessary, because even the most advanced AI model, AI tool needs reliable data. And in the modern energy system, we say that a modern infrastructure cannot function efficiently if the system is blind. So an AI model, an AI tool, it is as good as is the data which it gets. So that's why in the Republic of Moldova, we initiated this AI transformation by establishing and making functional the database required for this. So we speak about collecting the information from the consumers via smart meters. We initiated deployment of a country-wise smart metering program. We aiming by 2027 to have approximately 100,000 smart meters installed on the households. This will weigh to approximately 8% of our consumers. We are developing the national registry for consumption points. We are developing also the national energy management platform. And as well, we are developing the so-called national information system for energy efficiency. Together, all these four programs, four initiatives, will create the ecosystems that will help us to take better decisions, more efficient decisions, and that will prepare the ground for the AI applications, for a full deployment or for a complex deployment. But at the same time, the digital transformation required prior to adopt AI tools, we need to develop also the cybersecurity tools, especially in the energy. The most digitalized a system it gets, especially the energy, the highest are the risks. So that's why the digital transformation must go in parallel with the cybersecurity measures implementation in any modern system. So, but as I said, the AI is as best as the data which it gets, and at the same time, the AI tool should not only be, let's say, directed for the big businesses, for the big technology companies, or for the technological advanced users. The real success of the AI tool will be measured on the added value, how much value will create for the citizens of the country in which that model will be implemented. And the main goal, as I said, is the citizens, the consumers, and we aim that in the next 5 years, consumers will not simply receive once a month an energy bill, but they will receive and they will have access to a digital platform which can tell them where they can adjust the consumption, which measures they can implement to change their behavior as well. It will be like efficient decision-making process for every citizen. So this is the goal, the target that we are aiming by having the data, by having the AI tool to transform the energy system for the citizens. Thank you.
Thank you so much, Mr. Minister, for those very insightful things that you've shared. Particularly, I'm going to take away, your statement on AI tool is as good as, the data that it gets. So that's a wonderful statement, and congratulations on all the other initiatives that you have taken for the country, and very rightly pointed out that cybersecurity also, parallelly, when we are all looking at digitalization, we need to still ensure that, the systems are, parallelly secured, and a lot of new data points are coming in. So, we have to see that, we are parallelly also, having our systems in place for keeping the grid secure. So thank you so much for that. And with that, I'll move to Japan and invite Your Excellency Sako Hito. Japan has been managing a very the complexity and efficiency at scale for years now, and you've already set a global benchmark for the industrial energy efficiency, as I understand. So, as AI becomes a new instrument in that toolkit, where are you seeing the greatest opportunities that AI is bringing for you?
Well, Japan has a long, sorry, maybe it works much better. Okay, so actually we have a long history for the energy savings and, well, a lot of sectors in Japan. Since we had the experience of the energy crisis in 1970s. So since then, we have put so much effort for saving energy consumption. Well, of course, we all know that AI offers significant opportunities. So especially in the case of Japan, in the field of manufacturing, so that is a really big opportunity in space for utilizing AI. That we already seen the concrete examples. So, well, for example, the AI-enabled control automation system is being used to optimize the production and also utility operation. So not only in individual facilities, but also at the industrial complex, and also even at the level of the whole supply chain. So actually the AI is a new tool to maximize the energy efficiency. But at the same time, we have the challenge, namely that's the increase in electricity demand. So how to tackle this issue is a challenge for, especially I'm working for the energy agency. So that's a really big challenge for the energy agency.
Thank you for those remarks. I mean, very, very strong perspective coming from a very advanced technology, advanced country, and and you already have many measures, as you said, for energy ecosystem creation. So let me now move from policy to a market application operator. Ms. Rachel, from Octopus. Octopus operates at the interface of between technology and regulation, and and the consumer. That's the angle you bring in. So where do you see AI, already delivering measurable efficiency and results in your world?
Yeah, thank you very much. Look, I think we actually see the combination of electrification of consumer demand and AI as really transformational when it comes to efficiency. Those of us here already know that most electrical applications are much more efficient than their fossil fuel equivalents. So, EV is 3 times more efficient than a combustion engine, for example. But once that electrical appliance is joined with AI to allow the automatic management of that appliance, then you are really supercharging, particularly the benefits for the customer in cost savings, in terms of running cost. But then, so the individual customer is benefiting. But more importantly, if those assets, millions of assets, are being optimized to suit the system, then we're running a much more efficient grid and everyone can benefit. So for example, right now in Britain, we are facing skyrocketing balancing costs. Basically, we're wasting renewables. But if we are properly automating the operation of our electrical demand, then we can actually make a massive reduction in that wasted wind. And similarly, actually across Europe, those of you who are from Europe might not know this, but our distribution networks are that utilization rate is below 10% on average. So if you can flatten demand and use those grids in the troughs and avoid the peaks, then actually you are delaying the need for grid investment and keeping the cost of the transition down massively. So that is an incredibly exciting opportunity, win-win-win, because lower running cost of electrical appliances encourage more people to go electric, help us meet our carbon targets. And I guess we're probably going to come on to this, but I wanted to say this is not science fiction. This is happening today. I think Octopus is one of the European, if not one of the world leaders in this. So right now we are using AI to control about 450,000 consumer assets, mainly electric vehicles. That is a virtual power plant of 3 gigawatts. So that's equivalent to 2 of our nuclear power stations in Britain. And I'm talking about 1% of the vehicles on British roads right now. So the potential, as we electrify, to be bringing AI to reduce costs, not just for the user, but for the entire electricity system is massive and something we're very excited about.
Great. Thank you so much, Rachel, for the very practical perspective from how we can flatten the curve with bringing in more consumer participation. And yes, there's a lot of new elements getting added and demanding more power. And they can also definitely act as a virtual power plant. And in India, we have recently done a small demonstration on how these vehicles, which are moving with energy, which are the energy, resources, how they can also be, flexibility resource for the grid, and tested some vehicle-to-grid technology demonstrations have been done. So yes, I think with the consumer behavior and the kind of solutions you're bringing, I think we can do a lot with the AI tools to bring the flexibility that we are looking at in this ever-changing grid. So let me shift, my lens from a consumer perspective, an industrial lens, and bring in Mr. Julian. Alfa Laval, you work with industrial customers across the full spectrum of energy-intensive sectors. So what's your greatest opportunity that you are seeing with AI coming in?
Before looking at the opportunity, let's look at the dilemma that you started to hint. There is energy for AI and AI for energy. And we will succeed only if we make the balance right.
Absolutely. Yeah.
Because you mentioned that data centers are consuming a lot of electricity. That's true. They don't consume energy. They consume electricity, and they are fantastic at converting electricity into heat. And whoever is able to harness the power of that heat will actually make it super efficient. So I think we have a very big responsibility first to implement data center in a very responsible and efficient way. There is technology that is available to make data center efficient. There is technology that is available to harness heat in an efficient way. Coming from Scandinavia, it's a bit easier, or maybe in Moldova, you can do that as well. You can reuse that heat in a district heating network when you have it available. Might be more difficult in India, But there's other heat reuse cases that have to be developed and implemented, such as production of fresh water, production of cooling using absorption chillers. So there's a number of ways to implement data center in a responsible way to minimize the consumption of energy, or as I say, electricity, and make it efficient and integrated into the energy system, like you mentioned in Japan. Then the use cases for AI towards the energy system, they were a very good example, and I think it starts at the unit operation level, where you can optimize one unit operation through predictive maintenance. You can optimize a car, you can optimize the heat exchangers. We have every industrial company, a lot of the members of the energy efficiency movement, which we are a founding member of, have been working on a lot of use cases at the component level. I think quite interestingly is also on the system level, when you're starting to optimize the system. You mentioned the smart grid. You can do the same with district energy network, where you optimize the systems. You even out the peak load, as you were mentioning, Rachel, are really great example of using AI at the system level. And the last level will be the interaction with the human factor. How AI and the power of data, that is still the oil of AI. You need data, as you were saying very rightly, to make AI function, is going to enable behavioral changes or decision changes based on AI-informed recommendations. So I think those are the three levels: on the unit operation system and the interaction with human behavior, how we should see leveraging AI for energy efficiency.
Thank you. As rightly said, that AI is optimizing, the way we are using the energy. But yes, this is going to be very much required that we optimize how AI is using energy. So I think they have to go hand in hand, and all these new technologies are going to play a key role there. So thank you for bringing that perspective into the discussion. So with that, let me bring in Ms. Mary, and looking at a different lens now to look at how this is playing out globally, across utilities and the policy systems. And from Oracle, you work with the utilities, regulators, and policymakers across the world. So you see both the technology that is available, as well as the pace which is actually being adopted. So what's your single great opportunity that you see that AI can improve and bring more efficiency right now?
Thank you, Rina. And I don't know if this is good or bad for your panel, but I agree with everything that has been said, and I think we're all very much on the same page. So you're going to hear me double down on some of the things you've already heard. You mentioned this at the outset, and I think a few of you have as well, is there are opportunities now. AI has been leveraged for energy efficiency for many years now. And we've seen that in practice in the markets where we work. Of course, it's dependent on data availability, data quality, and data access. But through our O-Power business, which has the consumer-facing via utility engagement, we've leveraged machine learning to help utilities generate these highly personalized insights about how a customer is using energy, similar to what you've heard already. And by combining those very specific appliance level insights with very tailored recommendations, you help households save energy and reduce emissions. So that's happening today. But looking forward, I think one of the greatest opportunities, and I'll give sort of just a slightly different take on what you both said, is really improving the efficiency of the energy system itself. When you think about it on a macro level, we all have been talking about rising demand. It's rising for slightly different reasons in different places, but it's a challenge that almost every nation is facing. And historically, that means we build more transmission, we build more generation, and those are quite costly capital investments. And what AI will do is give us an opportunity to change that equation. In the US, the capacity of the grid through the year is at about 50%. So how can we use AI to leverage the existing grid, help utilities understand where capacity is available when, better forecast demand, connect the new loads in ways that maximize our existing infrastructure, and put off, delay, potentially, sometimes permanently, some of the expensive capital infrastructure that is needed in this moment of growing demand. So I'll stop there because everything brilliant was already said.
Thank you. I think you've, of course, summarized some of the points that have been said.
Sorry.
My job easy. But yes, that's an excellent, perspective that you've brought in, that how AI, instead of, can also help us defer some of the infra upgrades that, are needed with the growing demand. So, bringing more efficiency and the way we are using consuming the energy, and of course, the data that is coming in and, helping us streamline things better. So, any excellent perspective. So, we've heard very different, perspectives from policy and from government and, the consumer markets and, industry also working towards making, usage of AI more efficient, with data centers, new technologies coming in. And across, all the perspectives that have been put together by our esteemed panelists today, one thing that keeps coming back is that data is becoming the fuel of, the efficiency that we are looking at. So I hope you all agree on that point. So, with a lot of strong threads that have come out of this first round of discussion, and let me pull on few of those and come back to you, for another question that I have for you, Ms. Minister. That in the first round we all spoke about the opportunity part of it. Yes, that where AI can unlock efficiency, but of course before any of that can happen, countries need to have the right foundation, and some of the points you've already shared. That while many countries are still developing the digital infrastructure that are needed for the AI deployment, what should the government prioritize first? Should we go for digital infrastructure first? Should we, bring in, of course, I think parallelly we need to bring in the right skills to manage that, and regulations are key, and of course, everything, every change demands investments. So, what do you think is the first priority for, from a government's perspective?
As I was saying, the governmental decision should not come as a spare for any of this. However, learning from the experience of some countries which deployed significant data centers capacity, significant AI capabilities, we are observing that this high consumption of electricity, as Julian said, it's driving up the electricity costs. We observe markets worldwide where the affordability of energy, well, the cost of energy, it's significantly increasing due to the capabilities. So eventually the AI will help us to optimize somehow, but what the main focus should be, prioritizing the skills, prioritizing the digital transformation, it's to build those decentralized or microgrids in which the data centers, in which the AI facilities will be embedded, like some energy clusters. So we build first the skeleton, the energy generation, and close to it, we build the data centers that will operate the AI. So that, in our perspective, should be the path forward in order to protect also the households from increasing energy prices. Moldova is also deploying quite significant, already we have deployed quite significant renewable capacities. And we intend also to tackle and to attract investments in data centers in AI. That's why we prioritize, firstly, the energy clusters to make sure that when a data center comes to Moldova, it will have the right place to connect to the grid, will have access to affordable and reliable, redundant electricity. Otherwise, if you connect the data center directly to the grid, in an integrated market, in a market that will, in a situation that we are now working to couple with the European electricity market, we will observe a significant increase in the electricity price. So, as I said, as we are pursuing this endeavor, this trip, we need to be mindful as well about the electricity cost for the households, for the consumers.
Absolutely.
So, as the colleagues were saying, we need to find that equilibrium while allowing the technology to develop, but we need to keep because the investments have to be recovered mostly through the tariffs. So, tariffs, but as well, if we see increased tariff of electricity, then let's say a public argument will come up. But why we need this if in the pockets of the people we feel significant increase. So.
I think excellent point, Mr. Minister. And as you rightly said, that there has to be emphasis on the foundations that need to be laid out for, from the digitalization point of view, and the kind of upgrades required, so that tomorrow when we have these extensive loads coming in, so we should be totally prepared, and it should not hamper the the end consumer, going forward. And so thank you for that. And with that, let me turn to Japan, and you offer a very different lens, and where the energy efficiency has been long embedded, as I said earlier. So Your Excellency, how do you see AI strengthening the existing efficiency policies and supporting the transition towards increasing digital and electrified energy systems from Japan's perspective?
Well, as I said at the outset, so AI gives some great opportunities, but at the same time, we need to manage the challenges, namely that the rapid increase in electricity demand. So, the latest World Energy Outlook showed that, the increase of the energy demand will be it's going to be like 6% increase in coming 10 years. Actually, that's a lot. And then actually it's for the first time in nearly 2 decades. Because since the 1970s, we have so much efforts to do the energy saving, but because of the increase of the AI usage, we are going to have the opposite, the trend, the increasing energy consumption. So how to manage this is a really key, for the for us, to just unlock the the opportunity of the AI. So how to to manage this? Under the it's still under discussion, or some of the measures have been already implemented. But there are some examples that are we would like to decentralize the data centers to the areas where the clean energy are relatively abundant. So so as to reduce the transmission losses of electricity. That could be one way to do that. And another way is the implementing or strengthening the regulatory measures. In terms of data centers. Actually, in the previous session, I've heard the question from the floor that, in Japan, how to promote energy efficiency in the case of the air conditioning. And actually, for the, I don't know whether that person is still here or not, but but actually, we have a long history of the implementing so-called top runner program. So actually, what is that? Is that program was the it uses the most efficient product currently available in the market as the baseline to set the standards. So other manufacturers needs to meet or needs to match or even exceed that standards. So it's a kind of the competition in the market to set the target. And then, so actually, we have been implementing those kind of, the measures. But on top of that, we need to, strengthen our regulatory measures for the data centers as well. Actually, since this April, we started a new regulation on data centers. So newly built data center operational, around 2029, they need to achieve a power usage effectiveness of 1.3 or lower. So data center needs to meet that new regulation. So that's another way to do that. And also, another side of the, regulation, it's not a regulation, but the measure is, technology innovation, that is the key. So, so as we already seen that the energy saving for AI itself is critical. So, so the new technology can, pave the way for this kind of energy saving aspect of the AI itself. So, instead of AI cooled in the conventional air cooling system, maybe we can use the like liquid or immersion cooling, or another type of technology like photonic electronic convergence that can replace the electrical interconnection with optical ones, so that can dramatically reduce the use of the electricity, for the use of AI. So this kind of technology development could be critical. Still, the Japanese government would like to support, R&D or deployment of these technologies. So, combining those measures, then we would like to support the unlock the opportunity, but at the same time, to manage the challenges of utilizing the AI.
Thank you, Your Excellency. And you raised very valid points on on the preparedness side. Having the right standards, we need to have interoperable technologies, and excellent examples that you've put forward. And also the regulations, need to be in place for beforehand, so that when the planning stage itself, so that we have the right systems in place, and they're efficient from the word go. So with that, I'm going to move to Ms. Rachel, and where do you see, from your experience, which is the most promising real-world application of AI, and what are the measurable energy efficiency improvements that you see they are delivering today?
I mean, I think the real world opportunities are myriad. There's hundreds, if not thousands of them. But I mean, I just want to give you a couple of statistics. I mean, for example, research has shown that dynamic tariffs, and therefore the optimization of electrical load in Europe with high electric vehicle penetration, could be slashing the peak load by 24%. Equally, we already see that customers with solar and batteries that are operated in smart mode are reducing the peaks by 60%, their peak demand. So these are really tangible, if you like, system-wide benefits on top of the benefits that come to the individual consumer. So smart management of solar, battery, and heat pump in new homes is now allowing us to guarantee the owner of that home no energy bill for 5 years. This is the kind of future that we're building if we go electric and if we use AI to optimize the use of those assets to work with the system and help reduce the cost of the grids and help reduce the cost of balancing the electricity system. But I just wanted to pick up one step further when we come to data centers. Now, Britain has got an ambition to have 6 gigawatts of data center investment between now and 2030, right? So it's a very high ambition. And Centre for Net Zero is a research body that we set up in Britain, has actually done a whole load of modeling and released a really interesting report, which I can share with anybody who'd like to see it. But I mean, they're saying that not all, some data centers themselves can be flexible loads. So those with training workloads, if they're managed effectively, they can be reducing the peak 1% of hours on the system. They can be reducing their usage by 40%, right? That's a very significant reduction. And even those which are not flexible in themselves can be investing in behind-the-meter battery and renewables in order to reduce their contribution to peak. Most exciting from my perspective, as somebody who thinks about the mass market, about customers, is the opportunity for data centers actually to reduce their burden on the system, not by large behind-the-meter assets, but by funding the homes and businesses in their local communities to put in solar and batteries. And we're already beginning to see this happen in parts of the States. And we've got some of the hyperscalers right now working with us in Britain to do this. We've got a potential to be putting solar and batteries into the homes of hundreds of thousands of people who wouldn't normally be able to afford that, and at the same time, then reducing the average peak demand of data centers by about 20% in the winter. So, you know, we have got some incredible real-world examples right in front of us right now, helping manage the stress that data centers themselves place on the energy system, but also democratizing electrical smart assets for low-income homes as well.
Thank you, Rachel. I think you very practical perspective, from the energy side, energy efficiency side that you've brought in, and particularly, highlighting that, data centers, of course, there'll be energy. We see them as energy guzzlers right now, but they could be, the flexible load, in the future. So thank you so much for that. So I'll move over to Julian. Ms. Julian, the industrial systems are where some of the largest efficiency opportunities still exist. From your perspective, what do you think, industry is always under a lot of pressure to be able to bring productivity and competitiveness, and also have, their sustainability simultaneously. So how do you see AI, they're playing a key role in changing the industrial energy management and process optimization for the industries over the next decade?
Yeah, before answering that, I'm really happy to listen to all the conversation, not least from the policymakers, on addressing the location of the data centers, being closer to the renewables, so you minimize the loss in the grid, enabling heat reuse possibility, as I was saying, and this behind the meter story is also very important. I don't think data centers operators they don't do that because they want to do that. They don't build that, it's because of time. Mm-hmm. And here time is of essence. So here that's where we need a lot of work from mostly policymakers and authorities to really speed up the implementation of master plan to put those energy cluster in place, as you were saying, Your Excellency, and because without that, they have another race between themselves to win, and they will not wait. So they will be behind the meter, and they will, because they have no other choices. So in order to it's smart, because they will last for 20 years, those infrastructure. We have a big responsibility to put it in the right place, right. But we need to do it with really speed. Coming to your question on industry, I think industry is a little bit like you were mentioning in Moldova. We have for quite some time been lacking data in industry. And in a recent survey among 2,000 CEOs and decision makers that was conducted by the Energy Efficiency Movement, we have proven that availability of data was one of the hindrances for energy efficiency investments. In the previous session, we talked about how data is important to finance investment, but also to take decisions. We ourselves went into a journey to implement a full energy management system for our own company, and this has driven our decision-making process in order to really build a consistent roadmap for decarbonization. We're going to reach carbon neutrality on Scope 1 and 2 by 2027, by next year. And that's really thanks to that availability. Absolutely. And more we see our customers, our peers working on that really actively, because compared to maybe the consumer market, that might not have been as present and prominent as at least in every sector that it used to be. So this is really the big opportunity. First is to get the data, and then we will take the right decision based on those data.
Right. Thank you. I think excellent points there. From that criticality of data and using that for the right decision making. Let me zoom out now and look across the broader ecosystem. From the energy efficiency, and let me turn to Mary. Mary, across all the perspectives so far that you've been hearing from our different panelists, and from the policy, from the markets, from the industry. And so, we are hearing a common story that the technology is advancing quickly, and but adoption is still uneven. Mm-hmm. So, from many organizations that are exploring AI, but deployment remains uneven. And so, what is the biggest barrier that you see, from your lens and the global experience that you're bringing? That is preventing wider adoption and of AI-enabled energy-efficient solutions that we need for the sector.
Thank you for that question, and thank you for taking the perspective of the data centers and not me. I think what's really interesting is, at Oracle we serve all industries. I happen to be in the part of the business that's focused on energy and utilities and water. But we see a wide spectrum of how AI is being leveraged across the globe, as I said, through different sectors. And in energy and utilities, it has historically, even moving to the cloud, which, by the way, is a prerequisite if you're really going to take advantage of AI because of the volumes of data that it requires, that's difficult to get the energy sector. This all comes back to data, right? Where is the data? Is the data trusted? It's really trust in what we're leveraging around the security, the availability. And what I think we're seeing is utilities and regulators, they're cautious. And by the way, I understand why utility and meter data has been slower to move to the cloud and adopt AI, because there are a lot of reasons for that. But if we want these solutions to scale, they've got to be grounded in that trusted data, but they also need to be governed in a way that regulators, utilities, and the end customer, the end consumer can trust. Mm-hmm. And one of the ways we're trying to do that, that we've started to deploy, is dedicated cloud environments. So, there's public cloud, but there's also, very specifically dedicated cloud, where you can deploy that infrastructure specific to a jurisdiction, the location of its choice, capturing the benefits of cloud and AI, but still meeting those very strict security, regulatory, and data residency requirements. And there's one more I'll add that I think we need to work on in AI, which is, I think we need to make sure we're designing AI in this space to support, but not replace, human decision-making. I don't think that we're yet at a point where we're expecting a fully autonomous grid to operate on its own. I think the nearer term opportunity is AI should be helping humans make better, faster, more informed decisions. And so that, if you haven't heard it yet, the term the human in the loop of these solutions, I think, is really critical to get regulatory buy-in for these solutions to have greater penetration in the utility and energy sector. And I think we'll get there. But it takes time.
Thank you. I think this wonderful perspective you put forward, and yes, AI should support the decision making and not take over, going forward. But I think Mr. Minister was nodding his head. You would like to add anything to that from, from the government's perspective?
Yes, I would like to add the fact that, an over-regulation that may slow down the implementation, the deployment of technologies in fast-changing market conditions that could delay more and more the implementation. So by the time you arrive to the moment to start the implementation of a project, even a data center or an energy project, the market conditions, the prices for the commodities, they might be totally different.
Right.
So that's why also from the perspective of the government, we need to regulate the most critical aspects and try to deregulate some of the aspects that may not be critical.
Yes.
In order to streamline the project implementation. Otherwise, we are going to reach a moment, even it's happening also in the infrastructure projects, in the overhead power lines, which it's also critical to develop the AI, the data centers. Now the timing to implement a project from the financing decision to the commissioning in Europe could be between 5 and 7 years. And it's also the example of Moldova. While flying to Canada, I was comparing one of the transmission projects that we are doing in the country with some of similar projects in Europe. And I was let's say, worried that we did not sufficiently. But I saw that our project was in the current benchmark. But the reality, the current reality in the market is that you take a decision to implement a project, and by the time, because of the regulations, because of the bureaucratic procedures, the time you arrive to the moment to start building, the market, the prices are totally different.
Wonderful point. I know we are running short of time, but I'll ask the IA team, do we have some time for questions from the audience for our esteemed panelists, or otherwise I have a rapid fire question for everyone. You can go ahead with that. But do we have time? No, okay. So, okay, I think that brings me to the most interesting part of the panel today, with the quick answers, requesting all the panelists to take maybe a minute to give your perspective, last parting perspective for this panel. So, looking ahead, to 2030, and what single development and would you like to see and have, which will make the greatest impact in establishing artificial? I know you've already mentioned that we need to have the building blocks, but one thing, if you have to say to see as a major driver for energy efficiency with AI coming in, what would that be?
I will not change my mind from, like I said at the beginning, the reliable data is the key for AI models, for AI tools, to get and to offer solutions or optimize costs and for energy efficiency projects.
Okay, excellent. Madam?
Well, I believe that AI's, I already mentioned this from the technological point of view, that AI's own energy consumption is the key. And then, of course, the regulatory aspect is also the key. And I would like to just raise another issue, is the inclusiveness of the use of the AI. So in the case of Japan, the SMEs account for more than 99% of the total business entities that operating in Japan. So how to involve them, that's also another key point that we need to bear in mind.
Wonderful. Rachel?
Yeah, look, I think for us, we need a paradigm shift in the way policymakers think about the energy transition. We're still way too focused on building fixed assets and not nearly focused enough on the market and the regulatory arrangements that will reward flexible demand for supporting the system. So that's what we really need. We need to see that paradigm shift, new markets, price signals, and above all, making sure that we're not lumbering our customers with over-spec grids that could have been streamlined and made slimmer if we'd built the use of demand flexibility into our modeling of what grids we need for the future.
Thank you. Julian?
I will repeat myself. I think if we want to win the equation and have a positive sum game, we need to equally focus on the energy efficiency of AI and the AI for energy efficiency. And I would like to refer to we had earlier in this conference, we had the young generation competition, and they showcase a lot of use cases of AI to drive energy efficiency, and that makes me hopeful that we have a lot of potential in front of us.
Absolutely, yes. Mary?
Yeah, I think on the load, especially the data center load piece, I do think personally that AI to help AI, when it comes to, say, shifting and flexing compute power around data center flexibility is going to be the most interesting and impactful unlocking that we'll probably see in the sector. So.
Thank you. Thank you. I think wonderful perspectives coming from our 5 panelists here.
Someone would like to ask a question, I guess.
I don't know if you can allow that.
I don't know.
I think you'll have to take the question off stage maybe, with our, they're going to be around. So thank you to our 5 panelists for genuinely, illuminating this discussion with all the experience you're bringing in, on stage with not just ideas but real experiences that you've been, working with in making the systems more efficient and making this conversation even more illuminating. And so I try to step back and reflect on what we have discussed today and what we have heard. A few things that I would like to take away is that first, AI for energy efficiency. It is, we have the solution. It's already happening, in the grids, in the industry, and also, in customer-facing energy services, and they're there. But at the same time, there are gaps that need to be filled between, what is technically possible and also what is actually being deployed at scale. That remains a key significant point that needs to be dwelled upon. And, a few things, again, highlighting what stood out was one of the importance of foundational digital infrastructure that is required to be able to manage this. And because, you simply cannot run AI on systems that cannot measure themselves properly. So that is, one of the key things that we need to work upon. And another thing which you've already highlighted, that AI comes with the, it's a dual nature of AI, that it can both increase the demand as well as improve the efficiency. So we have to, work on bringing the best out of it, with having the right digital infrastructure and stuff. And what really matters is, the net impact, not just individual use cases. And of course, with AI, trust also is one of the things that comes first. And security, cybersecurity, we have to work on. Trust in data, trust in algorithms, trust in the institutions, and especially as AI, begins influencing the real consumer decisions. So, we have to be a forefront of, all our policies around that. So finally, distribution matters, and the benefits of AI will not automatically be equal unless there is a clear policy intent, and also to make it more inclusive, as you said. Yeah. So with that, to close, I would like to add that yes, AI is becoming a catalyst, which finally unlocks the overall efficiency in the system, and at speed, at scale, and also the scale that we have not seen before. So it's going to be a game changer if we are able to utilize it, to the right extent. But the real challenge of all of us that we're going to face, and we have to ensure it's, it is also equitable, transparent, and also very well aligned, changes with AI, with the climate goals that we have also, each country has put forward. So thank you, once again, please, give a big round of applause to all our panelists and for the wonderful perspectives they have put forward here. Let me thank His Excellency, Minister Doran, and also Her Excellency, Ms. Asako, and Ms. Rachel, Mr. Julian, and Mary for your contributions and bringing your experience and perspective here. Thank you, and this concludes our session here, and I invite you for a group picture in front of the stage.